Rational exponents. So radical expressions and fractional exponents. So we have two forms. This would be radical form. Again, this is on Edmodo if you want to take notes on your iPad, or you could just copy this down. This is called radical form because we have a radical. This is radical form. This expression over here is exponential form. Trust me, this is very, very easy stuff. It really is. Radical form, exponential form. We could go back and forth between the two forms. We could go from radical form to exponential form, or we could go from exponential form to radical form. What you need to know. Do you remember what this number is called? The number that's inside the index. The index. So the index, whatever the index is, it's always going to be the denominator of exponential form. The index is always the denominator. And this is our power or the exponent. The power is always the numerator. So when you go back between the forms, the index is the denominator, the power or the exponent is your numerator. That's how you go back and forth between the two forms. So, for example, say I give you the cubed root, the cubed root of y to the fifth. What form is this? What form is this here? Radical form. How can we write it in exponential form?
Would it be 5 and 3? Probably.
Yeah, y to the 5 over 3 power. That's it. That's radical form to exponential form. What if I give you this here? Can I give you another example? Brian, 2 over 2. X to the 2 over 2, which is what? X to the first. That's why the square root of x squared is just x. Does that make sense? You're just going from radical form to exponential form. What if I give you this here? What form is this here? Exponential form. Antonio, what's radical form?
7 square root with a z to the fifth.
There you go. We just say the seventh root of z to the fifth. That's all. That's all this says here. It's not hard at all, is it? Radical form, exponential form. So in this example here, if we have to simplify, you could just put in your calculator. So just do this in your calculator now, and I'll show you how to do it algebraically if you want to know why it makes sense. But if you see these questions, you can just simplify it in your calculator. But I'm going to show you algebraically so you understand the logic behind it. Oh, you all know how to get fractions on your calculator, right? So 27, the caret button, alpha y equals 1 to the third. What do you get? 3. Everyone knows how to put this in the calculator? Does anyone want me to show you how to put in your calculator? The answer is 3, right? Or if you didn't have a calculator, what form is this in? Angelina, question? Oh, divide by 3. Yeah, that would be 9 if you divide by 3. What form is this here? How can we rewrite it in radical form? Cubed root of 27 would be radical form. And what's the cubed root of 27? 3. So if you don't have a calculator, you could just rewrite it in radical form, and then you have the cube root of 27, which is 3. If you don't, if you don't remember these processes, put in your calculator and you'll get your answer. Does that make sense? You can just put in your calculator if you want. I'll show you how to do it algebraically afterwards if that's something you want to know. But these types of questions, put them in your calculator and tell me what you get. In. 8. Does anyone want to see how we would do this in the calculator? It's going to take me a second to get my calculator to load. But in the meantime, I'll show you how to do it algebraically while my calculator boots up. All right. So while the calculator is booting up, I'm going to show you how we could get this answer algebraically. What form? These are in exponential form. How can we rewrite this in radical form? So the square root of 2, right? So we have the square root of 2 times, and how can we write that in square root of 32? Everyone could easily change exponential to radical form, right? And now this is just 2 times 32. You got 8? All right, let's see. You got 8? All right, 2 times 32. Yeah, that is 8. Yeah. So 2 times 32 is 64. I'm bugging out right now. Sorry. All right, so that's the square root of 64, right? Which is 8. Square root of 64 is 8. That's algebraically, but here's how you just enter it into your calculator. If you had trouble with your calculator, please pay attention. So we have 2 to the 1/2 power. So it's 2. You see this button right here? You hit that button to raise it up to the exponent level. So now we could enter characters in the exponent. And to write a fraction, we hit alpha y equals. Enter. And then we'll just enter 1 over 2. Times 32. Hit the caret button. Alpha y equals 1 over 2. And we get 8. So if you don't have any variables, just use your calculator. If you do have variables, the calculator won't help you. You got to rewrite it in a radical form or exponential form, which is not difficult at all, right? All right, we still have some time. Next example. Oh, I don't want to close that, man. Now, this is the easy part. This is what form? Let's write it in radical form. Someone new. All right, Brian, go ahead. I only heard from you once. Fifth root of x. Any questions? Easy lesson, right? How about here? Ooh, all right. I got to teach you some stuff here. The exponent is negative. These are some exponential rules that you've learned in Algebra 1. I think we did it early in the year, exponent rules. Here's a list of all the exponent rules. If we have a negative exponent, is everyone paying attention? Before we could switch forms from radical form to exponential form, exponent has to be positive. We could write that down. Exponent has to be positive. And the way we turn exponents positive is that we take whatever the term is and put it under 1. So it's going to be 1 over t to the positive 3/4 power. This is one of the exponent rules. I'm not sure if many of you remember that. You have negative exponents, you move it down to the denominator, and the exponent becomes positive. So now we have a positive exponent. Now, how can we rewrite this into radical form? Just the denominator. T to the positive 3/4, how can we write that as a radical form? The fourth root of radical t to the third, all of that under 1. So the exponent was negative. We make this exponent positive by bringing it down to the denominator. Once the exponent is positive, we could go from exponential form to radical form. Let me give you another one just like this. Some of you look a little puzzled. Has everyone got this down?
Can I just see the answer?
Yeah.
Is it, what's it called? This, wait, never mind, let me write it down first. Someone else can go. Is it the square root of 3 and then x?
The cubed root.
Yeah.
So this is what I heard you say. Is that your final answer?
Um, yeah, that.
Yeah?
Do you have to put the 1 inside it?
Like over here?
Yeah.
You don't have to. You could, but it's not necessary. All right, one more with a negative exponent. I'm gonna give you two more with a negative exponent. That's one example, and here's another example. That exponent is negative, right? How do we make it positive?
Yeah, did we read the first one?
No. Yeah, there's a one. Now this exponent's in the denominator. I mean, this term is in the denominator.
Take the opposite reciprocal.
So we just have to bring it up top. So right now it's on the bottom. So you just write it up top. And now it's positive. It's just over 1. Now it's in the numerator. In the original example, it's in the denominator with a negative exponent. To make the exponent positive, it goes from the denominator to the numerator. And then you would just write it in radical form.
You're allowed to just bring it up from.
Absolutely. It's one of your rules. If you don't remember the rules, you have to refresh yourself on these rules with negative exponents. And I think we're going to have to continue tomorrow. But how about here? This is going to be 3y to the positive 3 over 4. So this exponent is this term is in the denominator with a negative exponent. To make the exponent positive, you just bring it up to the numerator. It's no longer in the denominator. You don't switch the places. You don't have to bring the 3 down. You just take this factor, this term, and bring it to the numerator. The exponent becomes positive. If it's already in the numerator, bring it to the denominator, and then the exponent becomes positive. Spencer.
When it's in the numerator, you just have to put over 1.
Yeah, if there's nothing in its place, then you got to put a 1 to hold the place of the numerator. But if there's already, so for example, that's a good question. Say for example, you have, say you have 2x to the negative 2/3.
Yeah.
This exponent is negative. To make it positive, you take it from the numerator, bring it to the denominator. It becomes 2 over x to the positive 2/3.
The 2 doesn't go with the x.
No, they're two different factors. There's a operation in between them. We just don't write the operation when they're right next to each other.
So if we keep the 3y to 3/4, or do we put a radical?
And then once the exponent is positive, then you could write it in radical form. So this would be 3 the 4th root of y to the 3rd. Next example. This chart is on page 383. This entire presentation is on Edmodo. So you can find it there or in your textbook. All right, now we're going to go in the other order now. Radical form to exponential form. Haley,
Um, never mind.
you've got it. No. You open the door, you got to walk through it.
Oh, it would be C to 4.
2 over 4. Can you simplify that?
Yeah. So C.
C to the 1/2. That's the answer. C to the 1/2. How about here? Now here it looks a little different. So whenever you see parentheses, that's the only difference. What's the index here? 2. It's the same thing. So it's going to be, whenever you see parentheses, pay close attention. When you see parentheses, you just put parentheses around the radicand. So the radicand is 7x. So it's just 7x with parentheses. And then what's the exponent going to be? 3 over 2. That's the only difference. If you see parentheses, just put parentheses around the radicand, and the exponent is still the same. Power over index.